Every time you check the weather on your phone, or you read a news article online, or even use an ATM, you're interacting with this hidden language. It works completely silently in the background, just making sure everything talks to everything else. Today, we're going to pull back that curtain and take a look at this language, XML.
So how does this hidden language actually pull it all off? Well, to get it, we need to ask a really simple question. What if data could just introduce itself? What if a piece of information could show up and say, hey, here's who I am, and here's what I mean? Just hang on to that idea, because it's pretty much the key to understanding everything about XML.
All right, let's dive right in. At its very heart, XML is the language that brings some serious order to the chaos of digital information. It's really all about one thing: describing data clearly and without any confusion. So let's break down the official definition you see here. XML stands for Extensible Markup Language. Now, the keywords to focus on are store and transport. It's not a programming language, right? So it doesn't do anything on its own. And this is a big one. Unlike its famous cousin HTML, it's not designed to display anything. Think of it more like a universal container for information, like a perfectly organized digital filing cabinet.
And this right here, this is the absolute core concept. If you only remember one thing, make it this. XML is designed from the ground up to be self-descriptive. The language itself explains the data that it's holding. The structure is the meaning, and that's exactly what makes it so incredibly powerful. To really get this, let's compare it to something you've probably heard of, HTML. Think of it like this. HTML is like a painter. It is totally focused on how things look. Its tags, like one for a big heading or another for a paragraph, are all just predefined tools for making things look good on a screen. XML, on the other hand, well, it's like a librarian. It could not care less about how things look. Its only job is to organize and describe what the information is. And the best part? The librarian, that's you, gets to invent the entire filing system from scratch. And that's where the real magic of XML comes into play. Since you're the one making up the tags, you're not just packaging data, you're actually embedding its meaning and its context right into the structure itself. You literally get to make the rules.
This slide shows a perfect, super simple example of what I'm talking about. Just look at this note. The tags, like the one for to, from, and heading, they don't exist in some official rulebook somewhere. Nope, the person who wrote this just made them up on the spot because they perfectly describe the data. A person can read this and get it instantly. And guess what? So can a computer.
And that is the big takeaway here. Those tags are completely meaningless until you, the creator, decide what they're supposed to represent. The structure you build becomes this universal key for anyone or any machine to understand the information inside.
Okay, now let's see how you can use this to build something a little more complex, like a restaurant menu. You can see the creator just defined a main tag for the breakfast menu. Inside that, they defined another tag for a food item. And inside that, they described all its properties with tags for the name, the price, the calories. You could see how you could just keep going, building this deeply nested, totally custom, but perfectly logical structure for any kind of data you can imagine.
Okay, so this is all pretty cool, but why does any of it really matter? I mean, why go to all this trouble? Well, because before XML came along, getting different computer systems to share data was an absolute nightmare. Seriously, imagine trying to have a conversation where every single person is speaking a totally different, incompatible language. That was the internet. A total mess.
So XML comes in and basically acts as this universal translator. And it makes four really tricky things suddenly super simple. It makes it easy to share data between systems that were never built to talk to each other. It makes transporting that data across networks a breeze. It lets you upgrade your platforms without breaking everything. And it makes your data available to completely new applications you hadn't even thought of yet.
The secret to XML's universal power is just how simple it is. As this slide shows, it's just plain text. That's it. And because it's just text, it's not tied to any specific software or any particular computer chip. A file that was created on a Windows PC can be read by a Linux server and totally understood by an Apple device, all without any special conversion. It's like a true digital Rosetta Stone.
Of course, for any universal language to actually work, there have to be a few ground rules, just to make sure everybody's playing the same game. But don't worry, the syntax of XML is designed to be incredibly simple and really logical.
So, the most important idea to get your head around is the tree structure. Think of an XML document like a family tree. It all has to start with one single ancestor at the very top. We call this the root element. Every other piece of data, every single other tag, has to branch off from that single root.
So, what are these golden rules for a well-formed XML document? Well, first, like we just said, you have to have one single root element. Can't have two. Second, every single tag you open, you absolutely must close it. Third, tags are case-sensitive, so a lowercase note is a completely different thing from an uppercase note. Fourth, elements have to be nested properly. And finally, if an element has an attribute, its value always has to be in quotes. That's pretty much it.
This slide is a perfect visual for that nesting rule. Just look at the incorrect example on the left. The bold tag was opened first, but it's being closed before the italic tag. That's a no-go in XML. The rule is super simple. The last tag you open is always the first tag you close. Think of it like stacking boxes. You have to take the top one off before you can get to the one underneath it.
So, now that we've covered the theory and the rules, let's take a look at where XML is actually being used out there in the real world. I guarantee you've probably used it dozens of times just today without even realizing it. It is everywhere. You know those RSS feeds that deliver news headlines to your favorite app? Yep, they use XML to describe each article with tags for the title, the author, and the publication date. It's the backbone for tons of financial transactions, for sharing complex weather forecasts, and for organizing these massive sets of scientific data. Heck, even a lot of the configuration files that tell your software how to behave are written in XML. And get this, the SVG image format? That's just an XML file describing a picture using math. How cool is that?
So, at the end of the day, XML gives us this powerful, universal tool to bring structure and meaning to the endless chaos of data. It allows all these different systems to speak a common language, and that opens up possibilities that we're still exploring today. The only question left is, now that we can give any data a clear story, what are we going to build with it?